of what you folks are doing. As Miss Duran mentioned earlier, and no relation to Duran Duran, the 80s band, by the way. I checked with her. No relation. Anyway, the point is, as Miss Duran mentioned, it's really admirable that you folks, could be preparing your classroom and, preparing your lessons and so on, but you've chosen to be with us. So we don't take that lightly. We really appreciate it. And we want to give you some really interesting data, tools, and approaches that you can actually use this semester in your schools. Now, one of the reasons why we get so excited about this, and I'm going to turn off my video just to save bandwidth in a moment so you don't have to suffer through this geeky vision of me up in Colorado, just up northwest of you right now. But I'm a big fan of El Paso. I've been to UTEP several times and worked with teachers in your district and your districts around you for many years. So, but one of the reasons why we get excited about this is because it's problem solving, right? You want your students to grapple with data. You want them to ask good questions. You want them to do some really deep inquiry. And to tell you the truth, it's a lot easier just to hand out a bunch of worksheets, right? It is a lot easier to do that and have them fill in the blank. But you teachers, you're the ones that really want them to dig into issues like land use change and population change and migration and climate and water and energy and all these key issues of our 21st century world, right? That's why you're here. You really want to dig into these things. Now, Dr. Mubako and Dr. Ontiveros, if she's around, Ms. Duran and I, we will be here for you, okay? You're not in this alone. And there are some, I think, compelling reasons why, in addition to the video that you saw, that I think make it worth your while as an educator to look into geotechnologies. Now, back in 2004, the U.S. Department of Labor said there are 3 hot fields for the 21st century: nanotechnologies, biotechnologies, and geotechnologies. And what we are anchored in these next 2 days are the geotechnologies: mapping, remote sensing, looking at the Earth from space or from a drone, from a UAV, or from airplanes, GPS, global positioning systems, you'll be going out in the field today, and geographic information systems, or GIS. Okay, those are the components in a geotechnology. Basically, it's about where. It's the where question, donde, right? It's all about the where, the whys of where, and I like to think about it as what's where, why is it there, and why should we care? Why should we care? So what's where, why is it there, and why should we care? Now, a couple notes as we get rolling here, folks, and feel free to ask questions. This is your workshop. It's not Dr. M's workshop or my workshop. It's your workshop, so we really want to make it valuable to you. But a couple of things as we get going. First of all, I think it's important to start small. We're going to show you some examples of educators and students. And by the way, it's really cool that there's a student among you today. Rock on, map on, that's awesome. But we're going to show you some examples, and oftentimes educators say, I want to do that. I want to go out in the field and collect all the tree species in my community and map it and analyze it and so on. Well, start small, but I think the key is to start somewhere. So we're going to show you sort of a lot of different activities over these next 2 days, but we're not going to have time to really complete very many of them at all. But we wanted to give you a wide variety of scales, different disciplines, language arts, math, biology, geography, etc., history. I wanted to give you a different sample of what you can do in these different disciplines, because I've looked at the attendance list, and it's very impressive that so many of you are from a wide variety of disciplines. And also educational levels, right? We've got primary, middle school, high school. And that's one of the reasons why I love working with geotechnologies. It really has applicability in lots of different educational disciplines and levels. So kudos for you for being here. Okay, now you are smart educators, and you know as well as I do that you cannot do everything that you want to do in a class period, in a week, in a semester. So you're very careful and cautious, and rightly so, about what sorts of tools am I going to use in my classroom? So you weigh the return on investment, right? Is the return on investment there? Now with geotechnologies, you know how oftentimes the students are like, why do we have to learn this stuff? Are we ever going to use this out in the workplace or, you know, beyond the classroom? Well, one of the compelling reasons to use this is that actually this is used. Now, I realize that not all your students are going to become geographers like me. Okay, that's fine. If they don't like geography, I can deal with it. Okay, I'm okay with it. I've come to grips with it. But that's okay, because what if they become a business person or a city planner or a wildlife biologist or someone in public health, right, or social services? They're all going to be using these technologies actually in the workplace. So it's one of those things where you can say, yes, you actually will be using this, and we are using the same tools that EPA uses, that UTEP uses in their research sections, in El Paso School District, right? Where the school bus is going to be routed, what schools should we open, what schools should we close, et cetera. The United Nations Environment Program, the World Health Organization, WHO, US Geological Survey, where I used to work, et cetera. I mean, there are loads of state, federal, private companies, nonprofits. The Jane Goodall Elephant Foundation, folks, they all use geotechnologies, okay? So again, it's a good, one of the reasons why you can actually have a compelling response to students when they were like, why do I need to learn this stuff? But more importantly, I think, even than that, is that it is this inquiry-driven, problem-solving set of tools, okay? And also, I just wanted to mention, don't get to thinking, you know, I've got to look at earthquakes or population change or wind turbines in Texas or international migration with these tools. Yes, you can do that, but every time we go through an activity, Ms. Duran and Dr. O and Dr. M and I, every time we go through an activity, I want you to think about, okay, how could I use not necessarily this activity, but the same kinds of tools and techniques for teaching what I teach. If I'm teaching about the history of Texas and northern Mexico, let's say, I can use these same tools in those lessons, okay? So that's what I want you to think about as we go through here. Questions, comments, complaints? Is anybody running out of the room screaming yet? Ah, no more, no más, no más. Okay, let's get into some hands-on. I'm going to share my screen. One of the things that I want you to pull up is this document right here. And I'm also going to turn off my video, if you don't mind, just so that we can save some bandwidth here. But that document that Dr. Mubako mentioned a bit ago, this is, are you seeing this Word document? All right, folks. So the reason why this document is going to be important through the next few days that we have together is that in the document, we have the links to all of the maps and activities, okay? So that way, we truly want this to be a hands-on workshop. In other words, we don't want you to just kind of watch what we're doing. We actually want you to do it. Now, Dr. M and Dr. O and Ms. Valles and Ms. Duran and I, we know a lot of teachers using this, geotechnologies, but it's even more important to give it to the students. So keep thinking about that. It's great if you become familiar and confident, and that's indeed our goal in the next 2 days. But at some point, we want you to have the students. Where's that student in the room? We want to have the students, right? They can do this. Look at that student doing it, okay? So that's one thing to keep in mind. I'm not going to show these other videos that you see listed on page 1 there, which is the day 1. I did show, well, Dr. M showed the why get excited about web mapping, why geotechnology. So that's video number 4. This geospatial revolution video, I'm going to go ahead and share my desktop here. And there we go. All right, so this, hopefully you're seeing everything I'm seeing here. Are you seeing this geospatial revolution screen here, folks?
Yeah, we can.
It's a beautiful thing. I'm teaching at the University of Denver as well as doing, teacher professional development. And I also work for Esri, more about that in a moment. But at some point, watch at least the trailer for the geospatial revolution. It's all about why these technologies are transforming decision-making and making our world more sustainable and people lead healthier and happier lives through this technology. Okay, so it has grand and glorious, implications. But at some point, you might want to watch that. I'm not going to spend time during our workshop here. But again, we have things in the document that you can go through at your own pace. Well, I don't want to go on and on about why I care about this so much, but the organization that I represent, Environmental Systems Research Institute, we are a mapping company, okay? So we have an education team that has existed since 1992, so we didn't just wake up yesterday and say, oh, we should be involved with educators. No, we actually been kind of hammering away at this for a quarter century now. And most of my background is at federal agencies, Census Bureau, USGS, NOAA. So I love data. I love looking at geospatial information. But Esri is all about supporting you in your work with GIS, and not just educators, but city planners, water resources people, wildlife biologists, etc. If you go to the About tab, you'll see sort of our three core beliefs in there at the bottom. One is science, one is sustainability, and one is education. So education is really fundamental to what we're all about and why we do what we do. And to support GIS, Geographic Information Systems in education, we, as you'll see, create data sets. We work with educators. We help educators with their curriculum development. We actually write curriculum ourselves, but we also collaborate with teachers and professors, and in large part to get their curricular ideas into lessons, books, blogs, etc. So basically, we do whatever you would advise us to do in terms of supporting you in your good work with geotechnologies, okay? Now, let's go to the outline, okay, folks? So pull up that outline in Dropbox, or if you've downloaded it to your local device, that's fine too. And let's go ahead and get going with this practical exercise number 1. It's number 9, it's point number 9 in your outline, okay? So let's start with that one. Give you a moment to pull that up. How are you folks doing? Everybody good? Muy bien. We're gonna have a blast today, folks. This is gonna be a series of, beginning with this activity, think of it as like mini bite-sized, I don't know, gluten-free geospatial nuggets. So on number 9, and I will chat with Mr. or Dr. M on the chat box here, so you guys can kind of keep me informed if you're right with me. But go ahead and click on that World Cup Stadiums, 2018 World Cup Stadiums document. So yeah, Dropbox, the outline for today, go to number 9, go to practical exercise number 1, and we're going to start with the short activities using 5 web maps, 2018 World Cup Stadiums. How's everybody doing? You got that World Cup story map up there? Are you still working on it?
We got it.
Cool beans. All right, hearing no objections, let's talk about this map for a bit, okay? There's a couple reasons why, when we were planning this workshop, we wanted to show this right away. Number 1, it's a current event, or a very recently occurred event, right? So think about, oh, I can teach about some current events, whether they're earthquakes, whether it's the bridge collapse in Italy, whether it's coastal erosion, whether it's some event that happened last week, or wildfires, or today, a tornado, whatever it is. I can teach that event with the spatial perspective, with mapping tools. And this is one of the reasons why I wanted to show this, is that obviously this recently occurred, right, last month, the World Cup. And the second reason why I wanted to show it, is go ahead and scroll through there, is that you can teach some spatial concepts with this map. So for example, as you look at the satellite image for each one of these stadiums, ask the students, okay, how is it oriented? Get them to use cardinal directions. Each one of these satellite images, north is at the top. And so think about the direction that the stadium faces. Get them to think about, oh, if I'm on one team and I'm going toward the goal, is the sun going to be in my eyes at a certain time of day, right? Get them to think spatially about where the sun comes up and where it sets and where it is at the middle of the day based on the orientation of these stadiums. The second, on a related note, we're on the second point, but if you zoom out on any of the satellite images, get the students to think about land use. You might, if you're at the elementary level and even the middle school level, what is land use, right? How is the land used? And it's affected by zoning. So as you get them to think about, okay, in El Paso we have commercial districts, we have industrial districts, we've got a university area right there on the hill, we've got residential areas, right? You don't just have like a hodgepodge of things. You've got certain zones where things can be. Same thing with stadiums. And also get them to think about, if you've got a big facility like a stadium, you've got to locate it where people can get to, right? So is it near like a big highway? So for example, I'm looking at this arena number 3. It's next to a really super big road, like a divided road. Okay, and then get them to think about, how do people get to these places? This particular one is interesting here. This number 4, it's near a body of water. So you can look at the map and you can look at the photos. You can navigate either way. But also remember, this is tied to a live ArcGIS Online, is what it is, web map. In this case, we're looking at the satellite image. And so if you zoom out on any of these, you see this big body of water. So scale matters. Get the students to think about, oh, this one is on the edge of the Black Sea. Big body of water. What countries border the Black Sea? You can weave in all kinds of things here in addition to soccer, okay? And the third reason why I wanted you to look at this map is, think about, this is a multimedia map that we call a story map, okay? It's a certain kind of story map called a map tour, T-O-U-R. And actually tomorrow, if you're still with us, if you haven't ran and screamed from the room, tomorrow we're actually going to build one of these. So you can see that, yeah, I can use these maps that other people have created, but I can also make my own. And I can have my students make their own. Let's say you're teaching about tsunamis of the Pacific. They could make a story map of, you say, okay, I want frame 1 of the story map containing the 50 major tsunamis of the Pacific. Frame 2 being Hilo 1946. Frame 3 is Japan 2011. And that's their story map with 3 simple things in it, and then that's what you assess using a rubric that you make up. And then they could also present about tsunamis or tornadoes or landslides or whatever, population change, with these story maps as their assessment tool. Ooh, so think about that. So that's the third reason why I wanted to show this, is from a technology point of view, that this is an actual story map that you can make and your students can make, okay? And it's also just interesting to look at the different stadiums, right, and where they are. So if I zoom out, now I'm at this scale, so you can inject a little bit about that scale matters. Look at where all these stadiums are located, right? So get the students to think about, what country is this in? Okay, it's in Russia. It's a big country. Talk about the size of Russia, etc. But notice, if you pan over, as I am, hopefully you're seeing this in the upper left of my screen, that there are no stadiums basically east of this one, Yekaterinburg Arena. So this is the one that is the farthest east. There's nothing east of that. Why? Well, pull up a different map that shows population distribution, and maybe a map that shows climate and weather. And right, the population in Yakutsk and out here in Siberia is very low. And it's not going to support having a big stadium. So get the students to think about the threshold and why things are located where they are, including stadiums, including airports. Why are airports located where they are? You're not going to have a big international airport in Fort Stockton, right? It's going to be in El Paso because it's a bigger place. So those are the kinds of things you can have the students think about while they're exploring this particular web map of the World Cup stadiums. Awesome. Questions, comments about that? I love this map. Go ahead and make note of this. This will be in the outline. The second one I want you to look at is, I'm going to turn off my video again. But the second one in here is mapping Starbucks. Okay, so go ahead and click on that mapping Starbucks in your outline, and you will pull up this. Okay. Now, again, remember my comments earlier. Hey, Joseph, I'm not mapping. I don't teach about distribution of businesses like Starbucks. That's not what I teach. Well, or I'm not teaching about the World Cup. I know that, but think about, you're trying to get the students to think spatially. These are little, again, short little gluten-free nuggets where you can get the students to think spatially about things. And the reason why I think that's important is because, we really don't teach that much in school, right? In my way of thinking, spatial thinking is sort of like, it's like the sand in a conglomerate, to use a geological sort of an analogy. The cobbles and the boulders are things that we teach as disciplines, right? Math, social studies, science, etc. But the sand between the conglomerate boulders is the spatial thinking. It's kind of hard to grab a hold of, right? You grab a hold of a bunch of sand at the beach or in this conglomerate, and it kind of runs through your fingers, right? So it's hard to grab a hold of, and it's hard for students to kind of think that way because they're not used to it. It's not something that we teach. We don't have a class in spatial thinking, but you use it all the time. You're packing your trunk for a trip, right? Where do the suitcases go, right? How do they get arranged, right? You're arranging your desk in the morning at school. How do I arrange things? How do I arrange my classroom, etc.? There's all kinds of spatial thinking that goes on. You're doing some errands around El Paso, right? I want to be most efficient on, time and gas. So I'm going to go to this store, and then I'm going to go to the library, and then I'm going to go to here, then I'm going to go back home. So lots of spatial thinking during the day that we really don't think about that much in a purposeful way. Now, these ideas planted hopefully through these web maps in this workshop will get you, okay, I'm empowered with, I'm going to pull up a map of Starbucks. And getting the students to think about the distribution of these things. In this case, it starts with Manhattan. So have the students think about, okay, who's been to New York City? Has anybody been to New York City? Let's look at maybe change the base map in the upper left to a satellite image so the students can get an idea of where the tall buildings are in New York City. Maybe they've seen ground photographs in the past. I'm going to change the base map to imagery with labels. So right away, if I zoom in even, I'm going to see that in downtown Manhattan, right, I'm going to see a lot more tall buildings than I will out in the eastern part of New York City, like in Queens or Brooklyn. Yeah. So get them to think about, okay, I've got a lot of tall buildings, I've got a lot of businesses and offices and so on and so forth. It makes sense that the density of people working there is high. And if I'm going to be smart about where I'm going to locate a business, I'm going to locate it where there's a lot of people walking by, especially for a place like, and get them to think about not just coffee places, but other kinds of businesses. What would be the kind of business that would rely a lot on people walking by? Convenience stores, etc. Okay? So another reason why I wanted you to look at this one is because this map is in ArcGIS Online, which we will work with extensively during the workshop. And this map, as you can see on the left side there, is a heat map. Now get the students to think about heat maps in the following way. Not heat being hot like temperature, but heat being dense in terms of a lot of things in a small amount of space, okay? And so the heat map here shows the density of these Starbucks with a hot color, orange, yellow, etc., where there's a lot of these concentrated. and cool colors, or, you know, blues, greens in areas with low concentration. So that's a heat map, and you will actually build one of these in our workshop over the next 2 days. That's just one way of representing data. Not the only way, but one of many ways that you have at your fingertips, okay? So if I then, in the upper right, ask the students, okay, where do you think Starbucks will be located in El Paso? Are there any in El Paso? So let's go here and go to El Paso in the upper right, where you can search on things. So if I type in El Paso, comma, Texas, the first choice there is great. I'm going to click on El Paso, Texas, USA, and I'm going to zoom over there, and I can see, now remember, I've changed my base map to satellite image. So I'm going to see the satellite image. And if I scroll in here, I can indeed see, I might want to change my base map back to, I don't know, terrain with labels. Let's just try another one. You've got a lot of base maps at your fingertips. In the upper left, there's the base map. So if I zoom in now to El Paso, and look, it says add to map notes. Let's go ahead and do that. Now I've got a nice little place marker on El Paso that I can come back to if I wanted to. Notice if you add to map notes, how it now has a layer in the upper left of the map that you can go back to. I'm going to add map notes. So now I can see that in downtown El Paso, there are a few of these. And there's also a couple out by the airport. Interesting. But they're not scattered around evenly. There's also some in Juarez. Okay? And another thing to note is that behind these maps is a spreadsheet, a database. Now, who all over there has made a spreadsheet in Excel, for example, in your lifetimes? Okay, everybody pretty much. So think of these maps as having their power because they have a database behind them. They're not just a bunch of points floating around in space. They actually have intelligence behind them in the form of a database. So think of it this way. The G part of a GIS is the map. It could be a satellite image. It could be a 3D representation of hurricanes, etc. It's some sort of map or image. The I part is the information behind the map. It's the database, the information, the I. So the G part and the I part work together in a GIS. And because they work together, we call it a system. So that's the S part of a GIS. So Geographic Information System. Now, the beauty of you fine educators doing this in the year 2018 is that you're on the web, right? There's nothing to install. You've got Chromebooks there. You've got iPads. You've got laptops of various kinds, correct? You don't need a dedicated lab. Like if Dr. M and Dr. O and Ms. Duran and I were doing this and Ms. Valles in the past, we would have had to have you be in a dedicated computer lab in your school with software installed and doing this. Now, there's still desktop software in existence in GIS, but like a lot of other things, this has migrated up to the cloud. Here's my cloud voice. Right? And because of that, you can do it anywhere at any time. So you've got these services, these web-based mapping services running in the background. And now if your students say, well, gee whiz, is there a Starbucks in like Fort Stockton? I don't know. Let's go ahead and find out. According to this data set, and that's a key with all of these instructions that you're giving the students, you always have to say, according to this data set, we're going to answer the questions. So according to this particular database, no, there aren't any in Fort Stockton, right? When you think about population base and so on and so forth, okay? So according to this data set, no. But are there any in Shanghai? I mean, this is a global data set. So in Shanghai, let's take a look. There's a lot, okay? So, and then get the students to do a little bit of research, find out how big Shanghai is, how big Fort Stockton is, and talk about why are there a bunch in Shanghai and not very many in Fort Stockton. I'm going to change the base map back to topographic just for fun, so I can see some of the terrain. Anyway, fascinating. But There's a lot of other tools that you use online, right, folks? Who's ever used, Google Docs or OneDoc, or you're using Dropbox right now, right? Yeah, so you've got it up in the cloud. Why do you put it up in the cloud? Why don't you just use everything locally like you did 10 years ago? So you can share, so you can collaborate. Exactly. And what's another reason? And think about, for example, music. You don't have all your music locally on your phone or on your computer anymore, right? You've got it up in the where? It's in what services are you running for your music? iTunes? Yep, what else? Spotify, Pandora, Apple Music, Amazon Music, Hoopla, etc. There's a lot of music services, and you don't really care where they are, as long as it works, right? As long as you can access ABBA's greatest hits, right? Okay. The point is that as long as your music services are up there, you're happy, and then you can access them on whatever device you want, and you can get it to it anytime. So the same thing is operating here with these web-based mapping GIS services. You can access them anywhere from any device at any time. And they're also connected to the field work that you do later on. So you can bring things in from the field and map it. Tree species, broken sidewalks, graffiti, water quality, whatever, light poles, etc., on your campus or in your community. And you can map it and then look at the patterns, okay? So that's, I think, one of the key advantages of doing this nowadays. If you had gone through this workshop 5, 10, 15 years ago, again, it would have been difficult to get the data in, and we would have all had to be in a dedicated lab, okay? So this is another map that shows, patterns and get the students to think spatially. So I invite you to explore more of that one. Let's go to the Fiery Cross Reef, that third one in that list, okay? Fiery Cross Reef. This is another current event, and there are a couple reasons why I wanted you to look at this one as well. You guys have Fiery Cross Reef there? Okay, so Fiery Cross Reef is part of the Spratly Islands. And so if you're teaching anything about geopolitical alignments and issues in our 21st century world, this is got to be in the top 10, because this has for many years now been a very contested issue, okay? So first of all, get your students knowledgeable, and I'm going to fire up arcgis.com here, about where this actually is located. So if I go up to arcgis.com, you don't need to go here in a separate tab right now, stay on Fiery Cross Reef, but I'm just showing you how I would introduce this. I would start with this live web map, interactive web map of the world, and I would say, oh, well, let's zoom into Southeast Asia, and I'm going to go ahead and now look at, okay, this is the South China Sea and the Spratly Islands. So get the students to think about the countries that are around there. If you notice this base map, I also have the National Geographic, and that's a nice one to use for looking at, country borders, because it kind of mutes other things. So we've got China up here, we've got the Philippines on the east side, Vietnam on the west side, and also Malaysia down in the south part. Okay, so this is the South China Sea, and that's where the Spratly Islands are. So coming back to our other map that we're looking at right now, now that the students are oriented on what countries have a stake in the South China Sea, well, this is what's happening. Again, get them to think about scale. Now we're zoomed in to a very large scale, not very much area, but we've got two different satellite images, as I've put together in this one, 2013 and 2014, left and the right side, as you can see here. This also uses what we call a swipe technique, and you can build one of these. This is a story map, once again, just like the World Cup stadiums was a story map. This is a story map also, but it's just a different kind of story map called a swipe story map. You've probably have seen these online, and the good news is in our workshop, you'll be able to build one of these. You basically put two different maps or images on the left side and the right side. And without any sort of coding required, you can build one of these. So think about, land use of Texas versus population of Texas, or precipitation in Texas versus population, or in this case, 2013 in one of these former coral reefs now being built on by the Chinese government. So why are they building there? What are they doing there? Get the students to think about this. Look at the changes, the vast amount of changes between 2013 and 2014. So you can see that they have built this harbor in here, and get the students to speculate what these big objects are in this harbor with these long tails. It looks like a tail on them, okay? What are those things? Well, have them dig a little deeper and do a little research, but these are the dredges, right? These are actually pumping sand and coral from the bottom of this harbor and pumping it onto the land to build the land. So they are gouging the harbor, and at the same time, they are building basically a island where it was formerly just a coral reef, as you can see here, just a year and a half earlier. So now get them to think about not just what's where, but why is it there, and then finally, why do we care? So what? So what if people are building on the Spratly Islands? Well, it has global implications, right? China asserting no, we are the dominant force here in the South China Sea. This is our territory, which of course is not settling well with a bunch of other countries. But also think locally. What are the environmental consequences of building on a coral reef, right? There are huge environmental impacts. I mean, think about, if someone were to build a military base on top of the Great Barrier Reef and off of Australia, imagine the international outcry, right? Well, something similar is happening here, although these reefs aren't as big as the Great Barrier Reef, but obviously massive amounts of species being affected by these artificial islands being placed here. So again, it has local implications. It also has global implications. And this, again, on a technical note, to get you think about, swipe story maps. More about this tomorrow, but really powerful and easy to use, right? Because I can visually see changes across space and across time, which is a fundamental theme that we're all interested in, right? We want to have students understand the dynamic Earth that we live on, right? Why the planet is changing, how is it changing, and a little bit, if I can be so bold, you being educators, should I do anything about it? Should I care about these changes? What can I do about it? Okay. All right. How are you folks doing? Everybody good with one more? Okay. I love this stuff. I truly do. And hopefully you're seeing, wow, this is pretty powerful. And this is just a tiny, again, piece of the overall goals that we have to look at the Earth in different dynamic ways. I'm gonna just pull up the Zika virus one here ever so briefly, because again, thinking about a current event or a current issue, if I pull up that Zika virus link, we're gonna see what we call the metadata, the data about the maps. You guys seeing Zika virus 1947 and 2016 there on that link? All right. Hopefully you've got this screen that I'm seeing right here, Zika virus 1947 and 2016. So a little background for the students. What is the Zika virus? The WHO declared the Zika virus a global public health emergency, and this map explores how the virus has spread since 1947. So again, as I mentioned in that video, that hopefully wasn't too much torture for you to watch earlier, but I'm really keen on having students be critical of the data, right? Maps in particular have sort of an air of authenticity, folks, right? In other words, people kind of think, oh, maps are correct, and therefore I'm going to trust them. Well, maps are very useful. They're all imperfect in some way, and we always have to be critical about, just like anything that we're consuming on the web, is it accurate? Can I trust it? Who made it? What scale was it created at? And so on. So this page, and we're going to go into pages like this as we move through our geotechnology workshop, folks. But I want you to not just kind of brush by these pages. Actually spend a little time with each one of these saying, oh, okay, now it was created in this date, and this was why it was created, and so on. So up in the upper right, there's a view application rectangle, sort of a bluish one. If you go ahead and click on view application, you're going to get this. So this is, again, a tool that you can either teach about the Zika virus in particular, but also I think the bigger goal is to, again, get the students to think spatially about how diseases actually spread. They don't just start randomly, they actually spread in certain specific ways. And in this case, you can scroll through different places that was affected and still is affected by the Zika virus, okay? So it's just another way to get the students to think about, in this case, country by country, and why it's a serious issue. As you can see right here, it is associated with a steep increase in cases of where the baby's head is smaller than expected. So kind of a serious thing and a very scary thing, right, for a parent. And so get the students to think about diseases actually have spatial patterns oftentimes. Flu virus, the bird flu virus, I've got a web map on that. Malaria, other things, okay? Also, think about other kinds of illnesses and diseases, right? Cancer has a certain spatial pattern oftentimes, certain kinds of cancers, etc. So that's why GIS is being used extensively in the health field. All right, let's do one more, and this will require you to do a little bit more intense mapping work, but I think this is a really compelling reason, again, for using these sorts of tools, okay? Let's go ahead and go back to our outline. We've explored the World Cup stadiums. We looked at Starbucks ever so briefly. We looked at the Fiery Cross Reef and the Spratly Islands. We just examined, again, ever so briefly, the Zika virus, which I encourage you to dig into more. Let's go ahead to number 5, investigating the Kilauea eruption using 2 different kinds of mapping tools, okay? So investigating the Kilauea eruption, that one right there. Go ahead and fire that one up. And I want to show you 2 different kinds of ways to investigate this particular issue. First of all, I know you've got some elementary and middle school teachers there. So you might want to start with, okay, what are volcanoes, right? If this is part of your volcano lesson or your plate tectonics lesson, I think a lot of these tools can be supplements to your lesson to kind of bring it alive with these mapping tools. They're not pretending to be the end-all be-all of everything you would teach about, in this case, volcanoes and earthquakes and Hawaii, okay? But they could be nice supplements to what you're teaching. And these supplements could be 5 minutes. They could be 10 minutes. They could be a half a class period. They could be a whole class period. See where I'm going with this, folks? That these could be supplements to your existing lessons. So in this case, it is a map tour story map. It's exactly the same kind of story map that the soccer stadiums, right? The World Cup stadiums map was. So again, you're going to build one of these tomorrow. So in this case, we have a certain kind of imagery that is becoming really popular. And indeed, Dr. M and others at UTEP actually teach courses using this technology, and that is UAV, Unmanned Aerial Vehicle, or UAS, Unmanned Aerial Systems, or sometimes referred to as drone technology, right? There's even some high schools that we know that actually have a drone, and they have their students actually take imagery with it. Well, we have a business partner called Hangar, like the airplane hangar. But it flew a bunch of imagery. And as you can see here, on the right side, you have the capability of looking at this in 360 degrees, up and down and so on. So it's really compelling imagery. And it's also really high resolution because these UAVs, right, unlike satellites, they're very low to the ground. They might be 500 feet, 1,000 feet above ground. So the resulting resolution of the imagery is really quite striking. So in this case, you could have the students look at the effects that this lava flow from Kilauea, from the 2018 eruptions, is having on local communities. So again, you can navigate on the satellite image in the upper left, or you can navigate with the photographs and see what's happening at each one of these locations. And in the interest of time, I'm going to skip to number 11. I mean, this is the kind of thing, folks, where if your students aren't saying, oh my gosh, look at this, then I don't know what to say. Then they must be asleep, because truly, and hopefully this would wake them up, because this is really compelling imagery here, folks. So I'm going to go to number 11, just because to me this is the one that really struck me as, wow, this is amazing. And look at the evidence of the Earth as a dynamic planet. So west of Makame Street, lava flows roll through Leilani Estates. And look at this. You've got this farmhouse that is being engulfed by this, and notice the color, right? It's this black pahoehoe lava, okay? That's flowing through this person's property. You can see some trucks here. Are they, get the students to think about, hey, are they evacuating? How fast does this stuff move? They've got a garden here that's being engulfed. Have the students look at something like this right here. These trees that are flattened, these palm trees that are on their sides. How does that happen? Well, the lava's heavy, right? It flows over these trees and breaks them off, and that's the result right there. And as it flows into these structures, right, it's hot as well. So these structures actually burn. So get them to think about that, and the spread as you can roll out and kind of look at where this thing was and all the smoke in the air from the hot lava flowing in. So that is one tool to teach about the local effects of something like a hotspot in the middle of the Pacific Ocean, namely Hawaii, has on local residents. On a broader context, get them also to think about, okay, we don't have lava flowing through El Paso, but you've had a history in the past of volcanic eruptions, right? You've got some cinder cones in the area. You've got some evidence of volcanics. But get them to think about, 2018. What kind of hazards does El Paso have? What would they say? What kind of natural hazards do you have? Okay. Yep. We kind of have the here by me in Colorado too. Flash floods, windstorms, hailstorms. I know occasionally you have tornadoes in that area, as we do in Colorado. Not very many, not as much as in the eastern part of Colorado or the eastern part of Texas, but certainly that's been an issue in the past. So we might not have earthquakes and volcanoes so much, but we have other hazards. And get the students to think about, every place has got its own natural hazards. And if this is part of your unit on science or geography or natural hazards, then this could be a very compelling tool to use, because it's actually from UAVs. And if you're interested in more UAV imagery, there's no shortage. Wildfires used for city planning, other purposes. Okay, let's do the last one here. And that is, if I go now back to, let's do this, folks. I'm going to paste into the chat box. Let's go back to the outline here briefly. Yeah, let's do this. Since I don't have a link actually in here for this, let's go ahead and, Dr. M, is it okay if I paste this in the chat box? Yeah, let's do this. Let's do a web search on GeoNet Kursky Kilauea. If you do that, you will find this page, right? So GeoNet, G-E-O-N-E-T, Kursky, my last name, and Kilauea. Kilauea is a bit tricky to spell, but I know you can do it. So do a search on those three words. And the very first thing that pops up in the search is going to be who's analyzing the eruption in Kilauea. And the reason why is because I want to show you, in addition to that UAV story map that we looked at, there's another pretty compelling and fascinating set of data that we can actually examine using ArcGIS Online, which is our web-based geographic information system. And this will give us a little bit more familiarity with developing your geotechnology skills, but also to get you looking at a different kind of imagery. Okay, how's everybody doing? So you've got those 3 search terms, and you did a search on that, and you're looking at this, who's analyzing the eruption in Kilauea, right? That post right there? Everybody good? All right, super. So once you pull up this essay, and we'll talk more about this when we speak about, okay, where can I go from here? What kind of training? How do I keep moving forward in my own journey in geotechnologies? This thing here that we're looking at is called GeoNet. It is a networking platform where you can ask technical questions of colleagues, you can start your own group and have discussions, etc. And my team that I'm on, this education outreach team that I described earlier, we post frequently to GeoNet because we want to share resources like the one we're going to explore here in a moment. So that's what GeoNet is, okay? So once you search on GeoNet Kursky Kilauea, you will click on that first link and you'll get this short essay. Good? In the essay, I wrote the following: 2 amazing tools, UAV imagery and Sentinel-2 satellite imagery. Notice that that one's a link. Go ahead and click on that link and it'll put you at another more detailed essay about analyzing the eruptions, okay? So just reviewing again, we searched on the 3 terms. We got a short essay, and in that short essay, we clicked on the link, and now we've got the longer essay. So now we're on using 2 new tools to analyze the eruptions in Kilauea. Everybody good with that? You guys wave at me or something so I know that everybody's okay. Oh, nice. Okay. So in this next section, I'd like you to, we're going to dive into ArcGIS Online again, which is our web-based platform. We're going to look at some new imagery from the European Space Agency, and it'll allow us to supplement what we've learned about in terms of the eruption in that last little unit in a different way. Again, it's different kind of imagery. This is only about 2 months old, and this is new imagery that's now inside this platform. So it kind of shows you that every time the platform updates, we have new capabilities that you can use in the classroom and new tools, okay? So on this longer essay, notice that we've got that story map that we just looked at the top of it, but right underneath that picture where we were just examining the UAV or drone imagery for the big island of Hawaii there is a link that says, ooh, another recent advancement is the announcement of the new Sentinel-2 imagery in ArcGIS Online. I want you to click on that link.
Sorry, Dr. K, can I interrupt?
Yes. Oh, sure.
What screen are you sharing with us right now? Here. Okay.
All right, very good. All right, folks. So just to recap, we did a search on these 3 terms. And the very first link was this, who's analyzing the eruption in Kilauea, right? We saw that short essay to introduce the topic. Then we clicked on 2 amazing tools, UAV imagery and Sentinel-2 satellite imagery, and we get a longer essay. The reason why it's a little bit longer is because I actually have some guiding questions that you can use in the classroom in there, and you can decide, no, I've got better questions, Joseph, I'll use my own questions. That's fine too. So if we go underneath that picture that we were looking at a moment ago, where you've got the property being engulfed by the lava, let's do the following. Just scroll down a little bit and let's go ahead to just a bit underneath that photo. Yeah, okay, so this link right here, You guys see that highlight there? Dr. M, has everybody seen that highlighted text? Okay, good. Yeah, that's the one I want you to click on, because then we're going to, once we do that, we're going to pull up this. This is, again, one of those metadata pages, the page that actually shows the information about what we're going to look at. Now, as we do that, you see that it shows that this is part of the remote sensing part of geographic information systems. This is looking at the Earth from space or from above. Now, we've already looked at some UAV or drone imagery, right? That was filmed at a very close proximity to the surface, right? It was maybe about 750 feet high. This Sentinel-2 imagery is from the European Space Agency, as I mentioned earlier, and it's got some wonderful capabilities that we don't have time to get into all of them. But for right now, let's say you're teaching your students about the electromagnetic spectrum, right? I oftentimes start with something that they are familiar with. Okay, when you go to the dentist, how does the dentist see through your cheek into your teeth? And hopefully the students would say, what? X-rays, right. So get them to think about that there's a lot of energy out there in the electromagnetic spectrum, only a little part of which we can actually see with our eyes. But with satellites and with other kinds of tools, for example, that the dentist even uses, we can see different parts of the spectrum. Now, for our purposes here, one of the reasons why we like to see things in different parts of the spectrum is that we can see different things on the landscape. So for example, with a certain wavelength, we can see things like pine beetle infestation in mountains. We can see lava flows. We can even figure out if there are certain deposits of minerals or oil and gas or something underneath the surface in certain kinds of parts of the spectrum, okay? So there's a reason we can see more effectively water pollution, or whatever we're wanting to look at. There are certain parts of the spectrum that we can look at and close off or shut off other parts of the spectrum so we can see things more clearly, so we can understand the Earth better. That's the ultimate goal. So if you're on this page that says Sentinel-2 imagery, geology with this DRA, which is dynamic range adjustment, more about that in a moment, that is the page I want you to be on. Okay, and notice in the upper right, there's going to be something called Open in Map Viewer. Now, you all have a login, correct, to ArcGIS Online? Either through your school or through Dr. Mubako. He's got a test series of logins if you need one.
All right. You want them to have the logins now, Dr. K?
Yeah, so when you folks click in the Open in Map Viewer in the upper right, okay, it's going to say, hey, this Sentinel-2 imagery that we're going to look at in a moment is actually something that you need to log in to see. Now we'll talk about in a moment more about this, but as you log in, I will explain what you can do without being logged in, what you can do with being logged in. In this case, since we want to look at this particular kind of satellite imagery, we have to log into our ArcGIS Online account in order to actually see it. Does that make sense?
Right. So Dr. K, I think you can share your screen. We are good to go. I think everybody now has an org to log into.
Very good.
So you can share your screen. I think we're good.
All right, super. How's this looking?
Yeah, we got you.
Great. Folks, let's just review a couple of things here that may be not as exciting as examining population, watersheds, energy, natural hazards, etc. But just for a moment, there are things that you can do inside ArcGIS Online without logging in. And we think that's important because, as we'll explore with some of these geoinquiry lessons, being able to pull up a web map without having to log in and without having your students need to log into anything is really important, right? You want to be able to teach a lesson in 15 minutes or 20 minutes and pull it up with the data layers there and all the maps available at your fingertips and no barriers, right? So that all being said, there are lots of things that we'll do without logging in, okay? So that's all in this ArcGIS Online platform. If I go to arcgis.com, you don't need to do this at the moment, but if I just kind of demonstrate what I'm saying there, if I go to map, there are no shortage of maps and data sets that I can actually analyze. Earthquakes around the world, you know, population change, history of Texas, etc. There's nothing to prevent me from going to this modify maps button up in the upper right and saying, oh, I want to add, oh, let's just look for, I want to look at rivers of Texas, okay, really simple. I'm going to go ahead and add that to the map. I'm just using the add button. I haven't logged into anything, okay, with this. Now I've got, oh, I've got rivers of Texas. I've also got rivers for the whole world, but it's scalable. So as I zoom out, let's say you folks that are teaching at elementary level and you wonder, you know, am I stuck with using this postage stamp sized map in my textbook? Well, no, you're not confined to using that map. You can just pull up a map like this and say, oh, okay, well, I'm going to look at just major rivers. Here's the Missouri, here's the Red, here's the Colorado, here's the Rio Grande, right? So I haven't logged in to do any of that. If I zoom in, now I can see not only more detailed rivers of Texas and northern Mexico, but also, what are these dashed lines? See this brown dashed line? What are those? There's a bunch of them around. Look at this one. It goes all the way up into Colorado where I am. What are those dashed lines? Watersheds, the watershed boundaries. You folks are good. Excellent. So as I zoom in, I get more detailed river data, but I also get the watershed boundaries. And you can even see the one that kind of circles El Paso on the north side, right? The one that goes right up to the New Mexico border and around. So that's a different watershed that you're in, right? The water in this area drains into the Rio Grande. And then, of course, the water over here to the east actually goes into this area and eventually over in this area over to the Pecos. So the point is that you've got, okay, I can do the same thing with show me major cities, show me GDP around the world by country, show me the 10 biggest cities in the Americas, etc. All that stuff is at your fingertips without logging in, okay? But to log in, you have several advantages. Number one, you can save a map, okay? Number two, you can share a map. We'll talk more about this later, but you can share it with your students can share it with each other. You can share your maps with your students. Think of it as kind of like a Facebook group. You've got a group of educators or students, or both, and you can share the maps with each other, okay? You can also share it with the whole world. So we'll look at some examples tomorrow of teachers and students sharing what they're doing so that other people can be inspired by their maps and their research results. So you can share maps, you can save maps. The advantage of saving it is, for example, I just pulled up rivers of Texas and the watershed boundaries, right? If I want to teach with this on Monday morning, first day of the semester, I'd have to do the same thing I just ran through. It only took me about 30 seconds. But if I wanted to go right to West Texas with the watershed boundaries and the rivers, and maybe I want the base map to be something like terrain with labels instead of topographic, I'd have to, if I want to come back to this exact same map, I'd have to save it. And once I saved it, then I could open it up exactly how I left it. Does that make sense? If I didn't save it, I'd have to create it all over again. I'd have to do the add data and add the water and so on and so forth, which only took a minute, but it would save a little time if I actually saved it and then pulled it up right away. Okay, so that is another advantage of logging in. You can save things, you can create story maps, and a whole bunch more. Okay, let's ditch that tab for the moment and ditch this UAV image. Okay, so right now what we did was we searched on, let's just back up for a moment, and we searched on GeoNet Kursky Kilauea, correct? And once that pulled up, we had a short essay that introduced the topic of, oh, I want to teach with some of these tools. And once we got to that short essay, it linked to a longer essay. And for example, pull up the data.
Yes, Dr. K.
What we did was we pulled up this who's analyzing the eruption in Kilauea, right, folks? And once we did that, we pulled up this longer essay, little guidelines for you to use in the classroom about, oh, we can pull up that UAV image of Kilauea, but now what we're going to do is, remember how we went underneath the photograph and we pulled up this geology with dynamic range adjustment, which uses the shortwave infrared along with blue in the third band. That's what we're clicking on now. And so now you should get, once you click on that, you should get this login screen once you go to this open in map viewer in the upper right hand corner, open in map viewer, and then it's going to prompt you, hey, you want to look at the Sentinel-2 data? Great, but you have to log in to do it. Is everybody good with that? Cool. So I'm going to open in map viewer, and it's going to say, okay, Joseph, what's your login name to ArcGIS Online? And you are all logged in to this particular map. You should see a global map with the Sentinel-2 data imagery on it, correct? All right, super. So folks, here's the bottom line of why I wanted to explore this with you. I know that maybe not all of you are teaching about natural hazards, and that's fine, but there are some fundamental GIS tools that I think will be helpful no matter what subject you're teaching. The first one is logging in, just getting comfortable with logging into ArcGIS Online. In the upper right now, you should have your name up there or whatever login you're using, correct? Mine says Joseph. Yours says T3G or something like that, right? Yep. Okay, good. And also you should, so that's one thing I wanted you to get familiar with. The second thing I wanted you to get familiar with is just doing a simple search on a place. So let's do that. Let's search on, up in the upper right, Kilauea. And as I start typing it in, get your students to think about, you know what? Spelling matters, especially when you're doing what we're calling here geocoding. Spelling actually matters because if you spell it wrong, it's going to have a difficult time trying to find where you want to go. Now, if I start typing in Kilauea, the actual one that I want is the third one down, the settlement lots, Hawaii, USA. Okay, Kilauea settlement lots. Uh-oh, the bell's ringing. You guys gonna hit the road? You're still there? Good. Well, thanks to Ms. Duran, we've got this wonderful facility. I just wish I could be with you in person. So sorry about some of these technical delays. Thanks for bearing with me. But Kilauea, I'm going to click on Kilauea settlement lots. And when I do that, here's another sort of GIS-y thing that we kind of need to go through. See where it says Kilauea settlement lots, and underneath in that pop-up box, it's got add to map notes. Let's add to map notes, okay? Then we're gonna get a little push pin on the result of our investigation, okay? So that's one way for you to kind of mark places that you want the students to look at. And of course, they could do the same thing. Another way of doing it is look in the upper right-hand corner here again, where it says bookmarks. Go ahead and check out that bookmarks. Think of bookmarks as places that you want to go to in a map. Just like, you know, how you use bookmarks for web pages, like I want to mark my school district's home web page, et cetera, et cetera. You know, unitednations.org, all kinds of other things you want the students to look at. So you bookmark those in the web. Same thing here. If you add a bookmark and you call it Kilauea, or you could just call it Hawaii if you don't want to. Now I've got that bookmarked. So if I pan the map, and you could just use the mouse or the touchpad to kind of pan out into the ocean. And if I pan out into the ocean, and if I click on bookmarks again and go back to Kilauea, I called it Kilauea Lots, notice it puts me right back where I was. So bookmarks can be really helpful. You can put a bookmark on Texas. You could put a bookmark for El Paso. Does that make sense? So bookmarks can be pretty powerful. Questions about bookmarks? I'm going to scroll out now. Let's say I'm teaching middle school. Maybe they have no idea where Hawaii even is. So I'm going to put a bookmark at the scale of Hawaii, and I'm going to call it Hawaii. So I'm going to make a bookmark. I'm going to add a bookmark, and I'm going to call it Hawaii. There we go. So now, if I use my bookmarks, I can go to Kilauea, and I can go to bookmarks and then go back to Hawaii. So now I don't have to zoom and pan there. I can just automatically go there. Does that make sense? Cool. So that's just a handy way of kind of navigating around the planet. You could have a set of bookmarks covering a theme. For example, large cities of Texas, or the highest waterfalls in the world, or places where deforestation is occurring, or big reservoirs like the Three Gorges Dam. Maybe you're teaching about that in China. Okay, so a little note about bookmarks. But back on our lesson here, what we want to do is we've got this particular kind of satellite image, right? It's this Sentinel-2 data. So again, thinking that it's actually filmed in 3 bands, 2 of which are shortwave infrared. So it's not how the terrain actually looks if you were looking out of a satellite way above an airplane. If you were actually able to be on like the International Space Station or something like that and looking out the window, this is not actually what you would see in the visible part of the spectrum. This is again, in shortwave infrared, but it's really fascinating, as hopefully you'll see here in a moment. This next part will bring up another key function of a GIS, and that is to filter the data. Now, oftentimes the challenge in teaching with geotechnology is that you've got too much data at your fingertips. You've got 600 cities for the world, and you really only want to look at 50. You've got all the water wells of Texas, and maybe you just want to look at the ones that have a very low pH, like they're acidic, they've got high acid, okay? So how do you filter the data? If you hover over the Sentinel-2 imagery in the left part of where the map table of contents is, see how you've got a little filter tool in there? Yep. So let's go ahead and filter the Sentinel-2 imagery to a specific date in our case. We don't want to look at the latest and greatest. We want to actually look at a certain date. Okay? So go ahead and click on that filter tool, and it's going to pop up a box. Okay? And if you have a filter on there already, go ahead and say remove filter. Now I'm going to filter, and I'm going to create a new filter. So I'll pause while you get to the filter tool, and let's create a new filter. Remove any existing filters that you might have on there. All good? All right. So here's where you're going to build an expression. This is kind of important to GIS work. Now, don't get too worried, because it's not like you're going to be, or having your students to be, coders or programmers, but a logical expression is actually a good thing for them to know about. So in this case, you don't actually have to build it yourself, because you get this nice dialog box. And so I want to say, ooh, the acquisition date of the image is on, and then I'm going to pull down the very last box in there. See how you get the calendar? Go scrolling back to May 23rd, 2018. May 23rd, 2018. So what we're saying to the GIS is that I don't want to look at every single image. I just want to look at May 23rd, and you'll see why in a moment. Okay, so acquisition date is on May 23rd. So this filtering is actually going to be really handy for you in the future, because you'll be able to say, I only want to look at the top 10 cities of the world, population-wise. I only want to look at the most destructive tornadoes that have ever hit Texas. I only want to look at the top 5 rivers in terms of volume in the North America, let's say. Okay, so this filter tool is actually going to be quite helpful in the future. So once you've got acquisition date is on May 23rd, 2018, go ahead and apply the filter. And you're only going to be looking at that image as of May 23rd, okay? So now go ahead and pan over a little bit toward the coast. Go east a little bit, okay? And hopefully you're going to be seeing, if you've got acquisition date May 23rd, this image that I've got right here. Okay, all good? Now, folks, allow me to have a little geo moment here. If this image doesn't make students say, oh my gosh, look at this, this is incredible, well, I don't know what to say, because this is just, I mean, look at this. You've got this lava flow. Again, it's in infrared. So remember our investigation with the UAV data? On the ground, this lava actually looks black, right? It's black. But in infrared, it's giving out heat, right? So it has, the way that we've rendered or visualized the image, we're looking at the hot lava flowing from this fissure to the coast. So if I zoom in a bit, notice you've got a measure tool. Go ahead and click on that measure tool above the map and measure it with the little ruler symbol. Now you can measure it in miles or kilometers or meters or feet, whatever you want to use for your units, and help the students to understand that, you know, units matter. Whatever you're using, you have to understand what they are. But I'm going to go ahead and click on that lava flow all the way from the fissure down to the coast.
From filtering.
Ah, sure.
So we'll get
Yeah. So I'm going to zoom out to Hawaii. I'm going to use my bookmark. Okay. So do you guys have the Sentinel-2 imagery geology with DRA map up? Okay, cool. So what I did was, underneath where it says Sentinel-2 imagery, to the left of the map is what we call our table of contents. And right now I've got a couple things in there. I've got 3 layers. I've got map notes, which was the little push pin that I sort of dropped on the map when I did a search for Kilauea. I said add to map notes. So I've got a one map note is all I've got. It's a little push pin, or a place marker, if you will, on top of my map. So that's that thing. Then I also have a topographic map as the base. Now I can change that, which I will in a moment. But the middle layer in there is this Sentinel-2 imagery, right? It's that stuff from the European Space Agency that we're so fascinated about right now, because it'll really show us the lava flow. So underneath the Sentinel-2 imagery is a filter button. And once I click on the filter button, it's going to pop up a little dialog box. And right now I've already filtered it. In other words, I've cut down the data in size or by date. And because I've already got one, I'm going to remove this so I can start over. I'm going to remove the filter. And now I'm going to go to filter underneath the, It's that thing that looks like kind of like a filter that kind of looks like a funnel that you would use to I don't know, in the kitchen. You know, you'd use a funnel, or changing the oil on your car, you'd use a funnel maybe. Anyway, it's one of those things. And so when I click on filter, it's going to ask me for an expression. Now it already builds the actual structure for the expression, so all I have to do is fill in the values. And I'm going to select acquisition date is on, and remember we said May 23. So if I use the calendar and just click on May 23, it populates it. So now I'm going to say create a filter. So I'm going to cut down the data set and just look at acquisition date is on May 23, 2018. Sound good? And then I'm going to apply it. Once I apply it, now I'm only looking at May 23rd. Now, how do I go from Hawaii all the way to Kilauea? Well, I could zoom there manually with my touchpad or with my mouse, or remember, I've got a bookmark set. So I can just go to bookmarks and go to my Kilauea bookmark. Yep. And then I'm going to pan over to the east a bit. And now I'm going to pause a moment while that imagery pops up in there. And then I'm going to be able to see what I had a moment ago. Okay? So that's how I did it. Any questions? Okay, not hearing any. The last thing that I did is I used the measure tool. So I went over here to measure above the map, and I clicked on the little ruler, and I said, you know, miles is fine. And I'm going to measure from the coast to where the lava starts. And it looks to me like there's this fissure, right? There's this crack in the Earth's crust, and I'm getting just a little over 3.5 miles. So if I change it to kilometers, I'm getting 5.6-ish kilometers, okay? And so that last thing that we talked about was, hey, you've got the capability here, and again, think outside the box. It doesn't have to be for volcanic eruptions, but anytime you've got a map in ArcGIS Online, as we demonstrated earlier, you can change the base map. So if you go to base map, you can change it. I'm going to select OpenStreetMap, which is a crowdsourced citizen science base map, because I want to investigate exactly what's happening on the ground. So if I go to, now I've got the Sentinel-2 imagery and an OpenStreetMap base. Now, inside if you hover over the Sentinel-2 imagery on the left side of the map, you see the filter that we looked at earlier, but just to the right of that, there's more options. It's an ellipses, it's a triple dots. So if you go to more options, see there's a transparency tool in there. If you click on transparency, then you can make the image semi-transparent, as I'm doing here. You've got a little slider bar. Ah, this is fascinating. And if the OpenStreetMap is behind the satellite image, then you've got the fissures on the satellite image, or you've got the fissures on the OpenStreetMap plus a semi-transparent view of the Sentinel-2 imagery. So now I've actually got the best of both worlds. I can see what's happening behind the scenes on the ground on a map, but I can also see the lava. Yeah. Really interesting. So that's the result. I started with ArcGIS Online. I went to the Sentinel-2 imagery. I zoomed over to Kilauea. I added a bookmark. I added a map note. And then I filtered the Sentinel-2 imagery on May 23. Then the last little bit that we did was I changed the base map to be OpenStreetMap and made it transparent or semi-transparent, so I could actually see that, oh, Leilani Estates, oh, I remember that from looking at that UAV imagery. That was exactly the subdivision that was being impacted by this latest round of lava flow. Interesting. So that's just one little investigation of a current event, and we're using the power of the data sets that we've got at our fingertips in ArcGIS Online. Now, as you folks know, especially those of you that are teaching middle school, you know, disasters are oftentimes a great way of getting students' attention, right? Because they're high impact, they're death and destruction, right? I mean, they're very compelling. And it's a good way for you to teach geotechnology skills and also some content, right? So this is solid, you know, earth science, geography, physical geography content about why natural hazards occur, where they occur, human impact from natural hazards, and so on. A hot spot in the middle of the Pacific Ocean, why this thing is even erupting in the first place, and so on. Okay, so there's some good content, there's some good skills, and there's also this whole, what I consider to be the third leg of this geoliteracy stool, the geoliteracy stool being content, skills, and the geographic perspective. So you're thinking spatially here. Why doesn't the lava flow uphill? Well, it can't, right? So if you look at the contour lines behind here in this map, you'll see that the lava is actually flowing downhill to the ocean. Comments, questions, complaints? This is the most boring thing you've ever seen, right? Hope not, hope not. And this imagery, this particular image set that we are looking at right now, this came online in June. So you're looking at kind of the latest and greatest, some of the things that you can actually do. Now we're going to step back in some of these exercises that my colleagues are going to lead and have you, okay, how do I actually teach with this? So we're going to start with some lessons and some other things so you can kind of step back. But this first part was just kind of to get you excited about, wow, I can look at soccer stadiums to eruptions to diseases to Starbucks. I mean, you've really got a lot of capabilities here in this platform. So just to kind of review, remember we were looking at this last thing was this Sentinel-2 satellite images. We looked at the hangar UAV drone imagery of the same area. We also looked at, here's our Starbucks map, if you remember this one. Again, this interface should start looking familiar because you've got, like with the Starbucks map, you've got some layers on the left side, you've got content, you've got a legend, you've got the capability of measuring and adding data and so on. And then we started off with this, a story map of the soccer stadiums for the World Cup and the shape of these things, the direction they face, the distribution of the points around, in this case, Russia. And then even backing up a little bit further, we talked about, you know, why we're doing what we're doing. My firm belief, folks, is that we are not just mapping just for the sake of mapping and looking at points on a map or eruptions or whatever. We're doing this because we want to dig deep into, again, the whys of where. Comments, complaints, questions? All right, well, how are folks doing? You need a break because we got just one more little exercise with me, and that's the Urban Observatory and the global migration. So do you guys want to have a break though? You've been kind of hammering away at this pretty hard.
Okay, guys, let's get going. I think Dr. K is breaking from his coffee break, and we've done our 10-minute break. Can you hear us, Dr. K?
Yes, sir.
Okay. Yes, okay. I was just reading through your latest chat. That's in order. So please take it forward. Yeah.
All right, super. All right, folks, greetings, welcome back. Did anybody have any questions about the last thing that we ended up leaving you with, and that was this?
Yeah, there was one, Dr. K. I think I want to share it with you.
I was actually just very interested in now that we kind of went back and we looked at you know, the date, the what is it called, the acquisition date, creating a swipe for something like this, that, you know, we could see it.
Yeah.
We heard it.
Mm-hmm.
And also going back and maybe seeing, you know, I know you mentioned, you know, it's an interest level, because it, you know, it affects people, it affects communities, but going back to maybe something like 9/11, and could we go back and see maps and create a swipe of that, you know, what it looked like, you know, maybe right before, during, and maybe after, something like that.
Yeah. A couple things. First, tomorrow we are going to build a story map, and part of the story map set of capabilities is the ability to make a swipe map. So we'll talk about that for sure. Good point, and we will definitely cover that tomorrow. Also, looking at historical change over time, there are a couple of really key tools to use. If you don't mind me giving you like a 2-minute demo, would that be okay?
Yeah.
Yeah, go for it.
Okay. One of which is this historical topo map viewer. Now, this is a web mapping application that's built on ArcGIS Online. And the nice thing about it is that it's USGS and ESRI getting together and scanning all of the topographic maps that the USGS actually created. So it's, in this case, unlike the Sentinel-2 imagery, this is just US. But if we look at like El Paso in this tool, and this is the USGS Historical Topo Map Viewer inside the ArcGIS Online platform, if we actually go to El Paso in here, then we're going to get this timeline across the bottom. And I can say, oh, I want to look at, let me move the chat box over a bit. I want to look at what downtown looked like before I-10 rolled through, for example. So if I look at, for example, 1896, I've got this literally tens of thousands of maps at my fingertips where I can look at change over time, and using the very same tools that you looked at earlier in terms of making some of them transparent, you know, being able to download them and actually use them in on a PowerPoint presentation or something like that. That's all quite doable. And again, it's US only because it's the US topo map, GS topo maps. But look at the, you've got, you know, what, 120 years ago, have the students look at where El Paso was actually located, the downtown core and how the streets were laid out. That still affects how they got to school today. That affects where the downtown is laid out, right? But there was no I-10. How did you get around? Well, there were a few roads, but mostly railroad. And that's what you see here on this topo map. So then you can go up to, for example, 1941, 70 years ago, and take a look at how the city had changed between 1896, in this case, and 1941. So again, you've got these abilities to go back in time and look at things. Now, being people that are critical of the data, right, you know that you're not going to have a satellite image, right, from the late 19th century. You're not going to have UAV data for more than 5 years ago because all those technologies came in after these maps were made. But it's really fascinating to be able to look at just a couple of frames and being able to do this kind of thing. And now I can see, okay, 1941, El Paso got bigger. As you can see here, the railroad expanded. There were no interstate highways, and the city went just a little bit to the east of where it originally was back in 1896. Fascinating to be able to do this. So that's one thing I wanted to share, is this historical topo map explorer. The other thing is the Change Matters viewer. And if you look up Change Matters viewer, you will see this link. And this is now a global data set where you can look at back to the 1970s or so with satellite images. It's a nice tie-in to what we just did with Kilauea, because you've got them in a variety of different parts of the electromagnetic spectrum. And so, for example, here, if you're looking at Mount St. Helens, you can see the change pre-modern eruption and post-modern eruption, and seeing, okay, this is what happened, this is why it happened, this is the amount of area impacted, and you can see some of the vegetation
destruction and also rebound after the whole place was designated as a national volcanic park. And since this is global, you can look at building on our theme of why we care about changes. We're not just looking at them because we can, but because we want to look at environmental, social, other impacts over time. And so, for example, the Aral Sea being at one point the 5th largest lake in the world, the water was diverted, as many of you know, and it's kind of like the Great Salt Lake. You don't have rivers flowing into it anymore, and the sea is drying up, as you can see here. And I can change the dates. I can change the image from natural color to other kinds of imagery. And again, the goal is, why should we care if the Aral Sea disappears? You know, so what are the health, economic, social impacts of diverting water to, in this case, grow cotton in the middle of, well, students can see Kazakhstan and Uzbekistan. And you could do the same thing for Dallas-Fort Worth. You could zoom to Dallas-Fort Worth and see urban expansion, or El Paso, or anything else. So those are two tools. One more, if you don't mind. But there is a Wayback called the Wayback imagery service that just came in this past July. Okay, so it's just a month old. But if you go to this Wayback Imagery Esri, if you just search on those terms, you will see the ability to get back several years using, in this case, higher resolution satellite images. And if I scroll down in that blog, this is again the Wayback Imagery Service. This hang in there for about 30 more seconds, folks. This is really pretty compelling too. So here I want to look at change over the last few years with a high resolution satellite image. What's changed in my community? Why has it changed? What do I predict it's going to look like in the future? So if we take this Wayback Imagery Service, and again, this is in ArcGIS Online, so it's the same platform we've been working in for the last 3 hours. If we take this image and we say, you know what, I want to look at El Paso. It starts with Las Vegas because of, you know, Las Vegas is a good one to start with because of so much massive change. But if we look at El Paso, and we then on the left side, once this finishes drawing, you can see, well, for one thing, I love having students looking at an image like this because they see that, you know, the arable land, right, that's been irrigated is really just this, as you know, a small wedge along the river. And you start going east and west of El Paso, right, you're in sagebrush and cholla and rattlesnakes, right? I mean, you're in semi-arid terrain. And so if I click in the upper left here, it only shows me changes on these dates. So I can go back to, for example, 2014. And if I look at your middle school, that's a middle school, right? Then I can pull up, again, not tens of years, but I can at least look at, as of this time, and more is going to be added, what the school looked like in 2014, or your school, your neighborhood, versus today. Okay, so I've got the 2014 image now. Hopefully you're seeing that. Then I can go up to 2017, which is the last image we have in this particular data set. And I can look at changes. I can also look at things like, you know, asking the students, is this a school day? How do I know if it's a school day or not? How do I know if this summer is summer or winter, right? Leaves on the trees versus leaves off. What about the time of day the image was shot? How do I know what time of day it was? So get them thinking about patterns and shadows and that sort of thing. Okay, so those are 3 tools to look at change over time. Hope that wasn't too much.